Okay, so in this J+2 tutorial video, I'll go over using visual metrics here to assess your unit quality and to be able to use these metrics to potentially remove false positives from your clusters and also do things like merge your clusters or delete a deleted cluster that might not actually be a well-defined unit. Then I'll also spend some time going over comparative metrics, which can be used to compare two units side by side. And I'll go over the visualizations J+2 uses, which is unique to the spike sorting program, and which a lot of other spike sorting softwares out there don't have in their package. So first, we'll start by looking at these two clusters closest to the MUA cluster here, and we'll start by looking at the single unit metrics. So we'll pick cluster 1, we'll look at all the waveforms for that particular cluster, we'll look at all the cluster residuals, we'll look at the interspike interval histogram of all spikes in that cluster, look at the autocorrelogram of spike times, and then we'll also look at violations of Chebyshev's inequality. And for those of you who might be unfamiliar with Chebyshev's inequality, it's basically a math theorem that states that no more than 1 over n squared, objects in your distribution can be more than n standard deviations away from your distribution. Okay, so we click the display button here, and we can immediately see that this is a well classified unit. It is a true unit. All the spike waveforms are similar across channels and within the same channel. The waveform residuals, which is essentially just the background noise of every sample in the waveform compared to the background noise of the channel itself, is pretty good. It's pretty even, essentially, pretty similar, except for the areas around the peak of the action potential or the rise of the action potential, which is inherently variable, so that's not too big of a concern. Then we can also look at the ISI histogram here, and sometimes you won't get anything that pops up. So if you right-click the axis here, you can redefine the parameters of the histogram. So maybe I want to look at a histogram of 50 milliseconds and in 1 millisecond bins. And so now when we click OK, we can now see that there's only actually 2 spikes that have less than an ISI of 50 milliseconds, but there's no at all refractory period violations. Then we can also quickly look at the autocorrelogram of spike times, and we can see that there's no random noise here, no chance of unit contamination, so that looks good. And then finally, maybe we'll check Chebyshev's inequality. Maybe we'll look at something that's 4 standard deviations away from the mean. And if we don't see anything pop up on our screen there, then we can go to the command window, and we'll see that we get the display message here that there's no violations of the inequality for this unit. So all in all, this is a well-defined unit. One last thing we can do is maybe select some of these. There might be a few waveforms here that we might identify as false positives. So this is being extra picky, but just for the sake of example here, I'll choose a few waveforms using the brush tool, and I'll keep shift selected so I can select multiple waveforms at a time. And then if I go down to this remove selected waveforms button, those waveforms will actually pop up in the J+2 main GUI, and then I can remove them from that particular cluster as shown here. Okay, so that's kind of what the metrics look like for a good unit. And now let's look at another unit near the MUA here, and this cluster is cluster number 6, and so we'll go through the same steps. So we'll select everything, we'll display these metrics, and right away we can tell that this is not a true unit. The waveforms don't resemble an action potential, they're super noisy. The residuals are all over the place. There's variability at all ports of the waveform, which is much higher, almost 2 times higher than the background noise for the channel. There's a bunch of refractory period violations, so ISIs that are less than 1 millisecond, a total of 12 for this particular unit. So we can just get rid of this unit right away. We can see that this is erroneously clustered. It might have just been a noise cluster, some noise artifacts, so we'll delete that. Okay, so now we'll move on to comparative metrics between two units. And in particular, we might want to look at unit 4 and 5 because they're very close together in this projection we're currently looking at in the concatenated waveform PC score space. and maybe there's some spikes that we want to assign from 4 to 5 and vice versa. So essentially maybe some spikes have been misassigned between these two clusters. So what we can do is we can look at the cross-correlagram of all the spike times from Unit 4 to Unit 5, and then also the silhouette scores, Mahalanobis distance to cluster center, and the L ratio, and I'll go over what those metrics are as we view the comparative unit metrics plot here. And we'll just wait for this pop up, and there it is. And so what we can do here is we can start by looking at the silhouette scores of each spike in Unit 4 compared to Unit 5. So essentially what this is giving us is every bar in this bar graph represents a spike. And for all those negative values here, it's saying that those spikes that were originally assigned to Unit 4, those spikes are actually closer to the cluster center of Unit 5 in Mahalanobis distance space, in a four-dimensional space. And those four dimensions are the feature we're currently looking at, which is the concatenated waveform PC score space. So what we can do is we can view these selected spikes, again, similarly to how we viewed the waveforms in the single unit metrics GUI. And these are the spikes that were actually closer to the Unit 5 cluster center. So what we can do is we can add them over to Unit 5 if we choose so. And even though they actually look farther away from Unit 5, keep in mind that we're viewing this in a 2D projection, not the 4D projection that the Mahalanobis distance is calculated in. So we can go ahead and add those to Unit 5, for example. And then lastly, we'll just show that the L ratio here requires a multivariate normal distribution. For more info, there's a link to the paper where the L ratio is calculated. It's a paper from the Busaki lab in 2005, and they talk about the L ratio, but one of the key assumptions behind that is that you need a multivariate normal distribution of your spikes. So lastly, we can go so instead of looking at the L ratio, we can look at the Mahalanobis distance of these spikes to the Unit 5 cluster center now. So now we've picked Unit 5 as our first unit and Unit 4 as our second unit, and we can see the overlap here between these two units. And again, we can do the similar thing. So essentially all these spikes highlighted here are closer to the Unit 4 cluster center, even though they've been classified as Unit 5 spikes. So if we wanted, we could reassign those, but for now we won't. Okay, so those are the general comparative unit metrics. It was a whirlwind tour through, but essentially they use the silhouette scores and obviously the Mahalanobis distance to the cluster center. Use the Mahalanobis distance to define the cluster center and then define spikes to that cluster center. So lastly, we can look at the output that we want to save. So you can just select all these all these checkboxes in the Save Options checkbox. And you also have the chance of selecting various features. So here I selected peak amplitude, power, PC scores, concatenated waveform PC scores, and also the width of the waveforms, maybe if we want to do some type of cell analysis, like neuronal cell type analysis. So then you just enter the variable that you would like to save your data structure as. It just has to be a variable that MATLAB can accept. And once you enter, you'll see that here that you get this variable stored in the workspace. And this variable runrat1, now maybe it was during a run session, so that's why we call it runrat1. It has every unit that we saved, and it has all the options that we wanted to save for that unit. So it has the spikes, the waveforms, the timestamps, all those features. And then the L ratio here is undefined since this particular unit was not multivariate normally distributed. Okay, so that was a whirlwind tour through using the metrics in JClass 2 and saving the output. And yep.